Hello everybody, today we are going to talk about scope, range of variables. Look, we can create a variable that is between opening and closing brackets, and that variables are called local variables. Variables that are outside the main function are called global variables. They are called global variables because they can be accessed everywhere. We can use them everywhere. Variables that are created here between the curly brackets can be used only between that curly brackets. Well, you might be, hey, but we have only here curly brackets. Don't worry, it will soon explain. So, I will create now a global variable, for example, like that, int global variable. And what is different from that guy? Well, when we try to, for example, send to the output value of that variable, so value of global variable is and local variable. And you will notice that in the first situation global variable is 0 and local variable is random number. So global variables are getting the default values at the beginning. Here we don't know what we will meet. Okay. I would like to add that we of course can't use variables before they are declared. So if I did something like that, int number 5, and I would like to assign here that number from here, we can't do that because in that place compiler is like, hey, I have never met that guy before. He doesn't know what is after, what is in the next line. Okay. Like I told you in the first lesson, we should be compilers and we should know about things like that. So when I meant that variable is global, I meant that it can be accessed everywhere, but after the declaration. Okay. So let's go back to that thing, and now let's talk a bit more about the local variables. Look, let's create something like that. Integer a equals 10. And now, if a equals 10, which is true, I want to do between the curly brackets here something like int result equals a multiplied by 10. And now I want to send to the output the result. So I'm just sending result to the output here. Let's build the program. As you can see, our compiler is saying us that we have error here. The result is undeclared. First, use this function. As I told you, the local variables can be accessed only between the closest curly brackets. So for that guy here, for that variable, for that local variable, it is between that curly brackets. After that closing curly bracket, the result is being destroyed. We can't access it anymore. The memory that this variable allocated is now free. Okay, so I can do it that way, but I can't do it that way. Remember about it. Of course, we can't also do something like that. When we don't need to use curly brackets. That variable is still cannot be accessed because it got destroyed in the same line, right? Okay, so let's get that thing to the comment, and we can get that thing to the comment also, into the comment. And now I will tell you about the common mistake made by beginners in programming. Let's create, for example, integer number, integer result, and now I want to take three numbers from the input from the user. So let's do it that way, so it will be faster. Of course, we don't need to repeat now enter number 1, enter number 2, enter number 3, but we'll do it faster. So we'll do something like enter, and I will say I plus 1, so it will start counting from 0 plus 1, so from 1, right? I plus 1 number, end line, and take that number and then add this number to the value of result. And now let's send to the output result. Of course, our result is going to be outputted here because it is local variable for that curly bracket, so it's not being destroyed here. But let's type here numbers like 3, 2, 3, and will the result be 8? Think about it. I'm telling you that it's not true. If you know why, it's very good. Well, of course, that way, or that way, sorry. And now build and run. And as you can see, here we have enter number, enter first number. And I will type 3, then 2, then again 3. And the result is 68. As far as I know, 3 plus 2 plus 3 is not 68. So something is wrong. I will try it again. Did I do something wrong? No. But here is very bad error. As you can see, that line is equal to result equals result plus number. So what is result at the beginning? We don't know what is it, because it is a local variable and this is the random number. We have to assign 0 here. So now when we type something like that, the result will be right. Okay, we have to assign 0 to the result. Of course, we had to assign 0 to the result because we were making the adding operation here. For the multiplication, we would need to assign 1 here. We have to give you the neutral value for operations. Okay, now let's see, let's talk about that guy here. I would like to say how many numbers we added. So we added I numbers. So in our situation we should see 3 here, right? And hey, what's going on? We can't do it. Why? Because that place, if we define here something, this is like doing something like that, okay? Inside the curly brackets. So this is the local variable for that curly bracket. So that variable is destroyed after execution of all instructions. When the condition is false, then variable I is being destroyed. Okay, so how to get that? How many numbers we added? We should just remove that guy here and do it that way. Now, when we added 3 numbers, everything works fine. As I told you, we don't need to give anything here, right? We don't need to put the condition. We don't need to put here an increment decrement statement. Don't worry, we don't need to. So in situation when we need that variable from here in outside the scope, so outside that curly bracket, we need to remember that we should put that guy here before the loop. Okay, that's all in the lesson. Thank you very much. Hello everybody, today we are going to talk about functions. Functions, as the name suggests, is something that is created to function. Functions are sometimes called methods, because we can imagine them as methods that help us solve problems. If I want to achieve a goal, I need a good solution, and this solution can be achieved by using, for example, method. Okay, so function is something that is created to solve a problem in a program. Function is constructed of many instructions. Main is a function, right? It is created of many instructions that are between the curly brackets, opening and closing one. So it's like a mini program inside our program. We can create many functions like that one here. But this is the main function that is invoking other functions, for example. And now let's imagine a situation. We want to write a code that would check if the data coming from the input is a number. Verification like that might happen in our program a few times. Without functions, in order to check all the numbers coming from the input, you'll need to repeat the same code many times. So let's do something like that. Let's create a variable, string temporary, and now let's ask for the number. Enter the number. And line. And like that. Now you might be like, hey, you're asking for the number. Why did you use the string here? What the hell is going on? Look, if we ask for integer, now let's do it that way. What's going to happen when I type something wrong? So I'm typing key. As you can see, he didn't ask me for the second number. Why? Because we have an error. So when I type something right, everything works fine. But when I type something wrong, you have an error. That's all. So that's why we are going to take the string here. Because string are characters. And look, we have the ASCII table. We can check what characters are in string. 48, 49, 50, 51, 52, 57, right? They are represented by that characters. So, how to check characters? I can do that way. Temporary of 0. And I will type, for example, and as you can see, I have the first character. I want, for example, second character. I will do it that way. So, as you can see, I got the second character now. It's 1. And I can check if that is that guy by using the conditional statement. Oh, cool. Okay, so let's create a loop that will check all the characters inside the string. So for integer I that equals 0, if I is lower than temporary dot length, and what's that? That thing is called invoking of function. That function is called length, and that thing here will be replaced by the length of string. So here we have, for example, 4, maybe 5, maybe 10, okay? So this is the function that was written by someone. We can use it. In order to use it, we are saying the name of function and then the parentheses. That dot here is a bit complicated right now, but it means that we are using the function that is connected with the string, okay? Let's remember about it right now that way. And we'll increment the I here now. Okay, now let's check all the characters. how to do that. If temporary of not 0 but all characters, we have to check every character, is lower greater than 48 and lower than in the same time 57, that guy here is saying that it must be that must happen in the same time, right? Because it is the conjunction. I talked to you about conjunction in the logical operator lesson. If you don't understand it, please go back there. So right now we are checking that set of numbers here from 48 to 57. So if that thing happen, it means that we have a number as a character, not something like that or something else. So we should indicate somewhere, so we'll create a variable that will indicate the true or false bool. The type of that variable will be bool, right? Because it can take on two values, true or false. And we could just assign here is number to false, to true. And then we can check if is number, then, so if true, then we can send to the output number entered properly. Otherwise, it means it's not true. Number wasn't entered properly. Okay, but hey, how we don't have the first statement in, so maybe we'll do it that way. Change that guy to false, but to make it right, we can use something what is called the negation. So we are changing 0 to 1, 1 to 0, and now let's see if it's working right. I'm typing, for example, right number entered properly. Great. Now I am typing something like that. As you can see, number wasn't entered properly. But our program is a bit slow right now. We can make it a bit faster. Look. Why should we check all characters? Temporary of I. Let's send all characters to the output that we type, right? I'm typing here something wrong, and as you can see, even if we meet the wrong character, we are still checking characters. Why? We already know that this is wrong, this is not number when we meet one wrong character, right? So after it, we could just do something like that, break, and now look, wrong character, and as you can see right now, we didn't need to run this loop that many times. Cool. We've just improved our program. It's a bit faster. Okay, that was just a bit of training. But hey, we are talking about functions today. So let's imagine a situation we need that thing to work 3 times. So I have to, of course, copy that. And look, that thing won't work because we can't define 2 times the same variable with the same name, so I have to delete that guy here. We are changing value here anyway, so we don't need to change temporary to anything. This guy must be changed to the default value, so we are doing it that way here. But we okay, and now let's build. And he's asking for first number, second number, and third number. Everything works fine. Cool. But hey, now let's change something. For example, I want to check if the first number isn't 0. So I have to check here, for example, if the first character, so temporary of 0, is equal to 0. Or I can of course use the 48 here. So I can also use here 0. Of course, if you don't want to look into that ASCII table here, we can use characters. Everything will work fine also. You can use it that way or that way. So if temporary of 0 is 0, I should say that hey, no, this is not number. Okay, so I have to also add it before all the guys here. So here, and well, if we have false here, why should we check that characters after it? We are losing the time, right? So let's do it that way. Conjunction is number. So both expressions must be true in the same time because we use the conjunction here. And now we have to again what? Oh my god, we have to change. Again. But everything will work fine. Let me do it that way. Okay, everything works fine, but hey, imagine a situation where you use that code about 500 times and now you have to change something. Oh, yeah, exactly. It will be very time consuming and for sure not entertaining thing to do. And that's why also we have something what is called functions. They can be written once and reused as many times as we want to. Wow, cool, that thing must be cool, but we still don't know how to create it. Okay, let's remove that thing here because I can't look at it. And let's create an easy function first, so we train it a bit. How to create a function? First we have to say what will be returned by our function. If our function is not returning anything, we are going to say something like void, because void is emptiness, right? Something, it is nothing. So we are not returning anything right now. By saying returning, I'm meaning that we want to return the value to the place from where the function is invoked. So that length thing is invoked, right? And we are and here we had what? We had the length of string. So that length function was returning int. So for sure the declaration of that function is starting from integer, right? Or anything what is integer. I don't know, maybe unsigned integer. I don't know exactly which one is there, but it must be integer number because it is length, right? Okay. And after it, for sure, there is something like length. So it's the name of the function. So let's create a function which we will call welcome. After it, we will create a parenthesis. Between the parentheses, we can place something what is called parameters. Parameter. Okay, we can place here something like that, but we'll talk about it later. We are right now making easy function, and then semicolon. This thing is called declaration of function. And this thing is informing our compiler that somewhere in this program our compiler will meet the function that is called welcome. Great. And he knows also that somewhere in this file he will meet the body of that guy. And the body means description of our function, and it is just definition of our function. To do it, you just have to copy that guy here and open curly brackets, and this thing is called the body function. And here we can say something. Hello, welcome in my program. For example, like that. And now we can invoke that function in other functions. So for example, for welcome, and to invoke function we have to use the parentheses, and now I will build and run that guy. As you can see, hello, welcome in my program. Enter the number. I'm not entering number because I'm not listening. Okay, so how it's working? When the PC meets that guy here, it's like, hey, I have the name welcome here. I have to look for the welcome function in our program because it's invoked. That parentheses are saying me that that function is invoked, and I am jumping to that code here, and I am sending to the output that thing here. Great. But that function is not returning anything, right? Because it's void. It's not returning that guy here. It's just sending it out something, just doing something. This thing is really not called a function, it's rather something called like procedure, right? So how to maybe create something useful? So something what will help us with that code here, right? Okay, let's create a function that will be called isNumber. So what will our function return? It will return bool. It will just indicate if something is number or not. So, I am returning bool right now. But we have to know what will be checked in that function. So we are going to take parameters here. Parameters are just variables that our function can take. So I write something like int string temporary, for example, string anything. And now I need to create the body of our function, and I just copied that guy here, so I'm not going to repeat everything. And now we don't need that guy here at all. We can just do something like that, return false, and I can also here return false, and then I will return true here. And don't worry, I will explain it soon. And now we have to invoke that function and send that variable, right, to here, because this is the local variable. It is only seen between that curly bracket, so we have to send that variable to that place. Now it will be checked, verifying. Let's check it's working. I will explain it very soon how it's working. As you can see, and we have to, of course, delete that thing here. And now we can build it and run, and everything works fine. Number wasn't properly, okay, and number on the properly. Okay, so what is that return here? What the hell is that? Look, how it's working now. We are entering the number. Let's assume it's like something like that, and our PC is like, hey, I have to invoke the function that is called isNumber, and I have to send to it the value from here, so 124 and key at the end. So I'm doing right now that thing here, and I'm checking if the first character is 0. If our number was like that, he would return the false, which means that he's not going to do anything after it. When the function returns the value, it's the end of execution of that function, okay? So it's going back to that place here, and that place here is being changed to false. So if false, and because it's false, it's going that guy here will be executed. Great. In our situation, it was something like that. So we'll go here and we'll check if the first character is between that numbers, right, between 47 and 57, because first character is not. So we will check again the condition, right, and we will check again, and when we finally meet the key, it will return the false, and bah, that's the end. That's why we don't need to in situation like that the break here, because after returning back, that's all. We are not going to execute the for loop anymore. Okay, so we don't need to use the break here. Okay, in situation like that, so when everything is fine, we are going to return true only when that instructions before didn't return the files. Okay, that's how it's working. So when it returns the true here, we are just going to send to the output number, enter properly. Great. Okay, now we will improve it a bit more. So I will create another function that will be called like that. Enter the name, and it will be not returning anything. And I will just copy that guy here. And now, as you can see, I am using in that function from here, right? We can do it. And now I will just do something like that. And number enter properly, number enter properly, number wasn't entered properly. Great, now I want to change something. Well, 0 at the beginning is good idea, so number entered properly. Now it's working good. Well, I'm going back to that. This, as you can see, it's working like I want it to work. Great. I changed it in 1 second. Wow! That's why functions are very cool. Okay. Now I like to add that you don't need to say the name in declaration of function for parameters. Here we have to, but here we don't need to say the name. We have to say the type. So if there were more more parameters, I would do something like that. But we don't need to add the name because it is not needed. It's the declaration. That thing is just here, so our compiler will know that there is somewhere function like that. That's all. Okay. Now let's talk about something what is called inline functions. Inline, it means that we have declaration and definition of function in the same line. How to do that? For example, like that. Double adding two numbers, double A, double B, and I am returning A plus B in the same line. Of course, we can do it not in the same line because we can just add the enters here, but the name is from that we can do that in the same line. And for operations like that, it's okay, but please don't. You can send it to the output, for example, like that. Let's take that guys to the command and let's build it. Oh, sorry. That semicolon should be here. And as you can see, we have 9, so 5 plus 4 is 9. And as I said, that inline function should be only for small operation. Please don't use it for something like that. Okay? Now I'd like to tell you about something very important. What if I wanted to change the value of variable from, for example, that place from the main method in another function? So I would create something like void change value to, and I would take the integer, for example, and let's well, we can do it in one line. It's the fast thing to do. So for example, like that, x change to 10. that function must change the value of anything sent to it to 10. So now I am going to do something like that I'm sending A, and now I am sending to the output A here. So will it be 5 or will it be 10? Maybe let's take it to the comment. As you can see, it's 5, not 10. Why? Why it's happening? Well, when we are sending anything to the function like that, we are copying the value. What does it mean? We are doing something like that in x a, and now we are making operation on copy of that variable. We are not changing value under the address of a, but under the address of x. And in addition to this, that variable here, right, is going to be destroyed after that curly brackets. So we change value here, right? We can we'll see that it's 10, but that's all. It was 10 here and only for the x variable, okay? Even if I change names, for example, that let's make it the same names like AA, still we won't change, of course, the value from that place here. And you might be, hey, but there might be situation like that when I need it. Yes, there might be situation like that, and when you need that, we will use something what is called pointers or reference types. Don't worry, we'll talk about them later. Right now we can't do that. Okay, now I would like to also add something about the main function. As you can see, hey, this is function, but hey, I don't see void, double here, anything. Why is it function? Normally we should do something like that. Add here something like int end. Say something like at the end return 0, which means that our program ended well. As you can see, process returns 0. Our IDE is doing it by default. As you can see, that it's returning the 0. But it's really cool because sometimes your program might not end well, and then you might, for example, do something like that, return 5 here or return 1 here, and you will notice that that guys here won't be executed at all. As you can see, process returned 1, and that guys didn't get executed at all. I could do something like that. If, for example, let's create character, let's take that character, let's ask for that character. If you want, do you want to end the program, for example, do you want to end the program, yes or no? And now it will be put into that guy here, right? And if character is or character is equal to that guy, then return, and we can end our program a bit faster. For example, I am asked, do you want to end that program? No. So the 5 was here sent to the output, but if I do something like that, yes, as you can see, our program ended a bit faster. Okay, so you might be like, also when the other status can be used. It is used when we are using our program from the outside. When I say outside, I mean using it from place like that. So I can use my program from here, and we'll talk about it later. And then our program can be used by other programs, and then that status might be useful. Right now they are not so useful, right? We can also send to our program some arguments, and so we can declare parameters here like arguments, character, like that. We can do that, but right now we don't need it. Okay, we'll talk about it later. Right now we know the basic of functions and we are starting the true adventure in programming. Okay, that's all. Thank you very much. Hello everybody, today we are going to talk about overloading functions and we'll train a bit functions. First, let's imagine a situation like that. I want to write a program that will be able to raise to the power of some kind of the number. Let's write something like that. 2 raised to the power of 3 is equal to, well, that thing is called base. That thing is called exponent. And when we want to raise 2 to the power of 3, we have to multiplicate that guy here, the base, 3 times by itself. So I have to multiplicate 2 by 2 by 2. I have to do it 3 times, and I have to multiplicate that guy here. And why I'm saying this? Because we want to write function that will be able to raise to the power of something, okay? And now, so what will return our function? I think it can return the integer number, and we'll call it power, and it will take 2 integer numbers, the base and of course the exponent. Okay, we have the declaration of function. Now we'll create the definition of function. So let's call that guy b from base and that guy e from exponent. Okay, and how to do that? Well, we have to multiplicate that many times that guy here, right? So let's do it in loop, of course, because it's a very good idea to use loop here. And we are going to use the while loop this time. So while, for example, a is greater than 1, we are going to multiplicate what? B equals b multiplied by what? You want to multiply it by the base. Right now we have base here, but we are right now assigning something to the base. So we are overwriting that guy, right? That won't be the base, because when we multiply, do something like that, we would have, for example, here 4, then we would multiply 4 by 4, and then it would be 16 here, and 16 multiplied by 16. So we have to have the base somewhere stored. So let's create a temporary variable and assign b here, and we'll do something like that, right? Okay, and now that condition will always be true. We have to decrement that guy, and as you can see, exponent is telling us how many times we have to do something, right? So it's a very good idea to use it as a condition. Okay, so let's see. Oh, we have to return the value at the end. And let's use that guy, cout power, and for example 2, 3. So the result should be what? 8, right? As you can see, the result is 8, so everything is working fine. Well, we can write it a bit more confusing, but it will be having less instructions. We can do it that way, because this is the post decrementation, right? And we can, of course, use here something like that operator, which means the same like that, of course. So it's a good idea to do something like that. Let's see, it's working fine. Everything works fine. Maybe let's train a bit before we talk about overloading functions and other things like that. Let's imagine what would happen if I were PC right now. So, I am PC. Hello, I have to include the IO stream, I have to use the namespace. And hey, I have the declaration here. So it means that I will have somewhere in our program the label power, and it will take 2 integer numbers and it will return the integer. Okay, so I know that there will be something like that. Then I am going into the main function, and hey, I have to send to the output the result of the function that got invoked here. And it got invoked with two arguments, 2 and 3. They were sent here, so they were copied to the variable int b and variable int a, and here we are making the temporary variable. Well, let's maybe do it in the comments so it'll be easier to follow. Temporary is right now what? Maybe let's temporary is right now 2, right? And what's going on? We are checking the condition. If e, which is right now 3, is greater than 1. Yes. And after checking the condition, I am decreasing that guy. Bach. Okay, now we have to assign to b, which is right now 2, multiplied by temporary, which is 2. So right now b is 4. Great. And what? I have to check condition again. Is 2 greater than 1? Yes. So I'm going to invoke that instruction after it, but we have to first decrease e. So right now it will be 1. And I am multiplying the b. So right now b is 4. 4 multiplied by temporary, which is 2. So right now b will be 8. We are checking the condition. If a, which is 1 greater than 1? No. So we are not going to invoke that instruction anymore. And we are going to return b to that place. So right now here there is something like that. Okay. And we are returning the 0 and everything works fine. Great. Okay, so we just trained a bit, and hey, I would like to send, for example, something like that. And Bach. We can't right now raise to the power the double number, right? The real number with the dot, right? So, we need another function that could take the double. You know, we can't have two functions with the same name when they looks like that, when they have the same parameters here, with the same types, okay? But we can have two functions that are the same name with different types in parameter. So right now we can easily do something like that. And now, as you can see, oh sorry, here I have to of course b and I, and now as you can see everything works fine. We can easily run the program, and this thing is called overloading functions, because we are overloading that name, right? We have two same names, and our PC knows which guy to execute, because he's like, hey, I have the double here, so I have to take that function, not that function. He knows which one he must invoke, okay? Or let's make a bit different that function, so we will notice that he's invoking the right function. For example, let's do in that function something like that. We will send to the output every time we'll do something. For example, that 2 raised to the power of 3, something like 2 raised to the power of 1 is 2, 2 raised to the power of 2 is 4, 2 raised to the power of 3 is 8. So we are going to send to the output all these steps, right? And how to do that? Let's create, for example, temporary variable I, which will take, which I will assign to 0. And right now I will do something like that. When I is lower than exponent, and I will increase I right now, so I'm going to have the additional number, because we can't use the exponent right now, because we want to start from the low lowest exponents, and let's do something like that. C out, and so we are raising the base, and our temporary base is here, right? So we are going to write something like that: temporary raised to the power of, and our actual power is here, so that is equal to, and the result is here. And now if I do something like, for example, that, you'll notice that so something is wrong, because 2 raised to the power of 1 is not for sure. We should first do it that way, and now you'll notice that the results are fine, but that result is not good, because 2 raised to the power of 6 is not 128. So because of that, we are going to also do something like that. If I is not equal to e, we can multiplicate, but otherwise, so when it's the last run, just do not do it, and now the result is also fine here. Okay, so but the most important thing is that you should notice that when we are doing something like that, we are invoking that guy, right? Because our PC knows, hey, there is integer, so we are going to use that function. But when I use something like that, I have double first, so hey, I will use that function. So I didn't send the steps to the output. And you might be now like, hey, but you could do it that way, because double is wider than integer and everything would work fine. You could do something like that. And hey, look, we have the result still. Why did you tell me about that? Because we were operating on integer, and why send integer to double? Why take more memory? And maybe sometimes there were some operations on integer that will be faster. So that's why overloading is good idea. So I'm going back to that place. Now everything works fine, right? When I do something like that, our PC knows which guy we want to choose. Okay, that's all. Thank you very much.